Welcome to the Radiology Field of View podcast, the show that explores a wide range of innovations, challenges, and opportunities in radiology practice management today. I'm your host, Dr. Benjamin Strong, Chief Medical Officer at vRad. In each episode, we'll speak with imaging leaders for their unique perspectives and practical insights to help move your practice forward. Let's get started. Welcome to another edition of our radiology podcast, Field of View, here at Virtual Radiologic. I am Dr. Benjamin Strong, the Chief Medical Officer of vRad, and I'm joined today by my colleague, our Chief Operating Officer, Joe Schmugge. Thanks for being here. Actually, I do have to say, Joe and I have worked together for a very long time. Now, Joe and I have worked together for 21 years here at Virtual Radiologic, and Joe, in fact, started a month before I did, and that means he, of course, outranks me. But he has been kind enough to join us today, and we'll be discussing artificial intelligence, its development, utilization, operationalization here at vRad. We've been working in artificial intelligence since about 2015, I think, at this point, and so have quite a bit of experience with it, understand its uses, but of course its shortcomings as well. So we'll be talking about its use in dictation for radiology reports. We'll be discussing the strategic selection of artificial intelligence algorithms, a process that vRad has developed and applied to our artificial intelligence offerings. And then we'll be talking about data normalization and the way that it has enabled all our artificial intelligence efforts and how it has manifested in our radiologist workflow. So that's our plan for today. And again, thank you for joining me, Joe. We'll start with a discussion of ambient dictation. So this is a real-time, ongoing dictation process that allows a radiologist essentially a flight of ideas or free-form dictation that will ultimately be parsed and categorized into a proper, organized radiology report. So I have my opinion of this, but curious as to what you've seen out there and how you think we might use it.
Well, I think it's a very cool update in the market. And in terms of the utility, if you've done a great job with report templates and with data normalization, which might not sound like the most exciting topic, but I'll tell you, it might be the most important topic in radiology, then ambient listening might not sound that exciting, except if you've ever watched a radiologist dictate a report, then you'll see them make their finding, and then they'll say something like, period, new line. And they will actively dictate not just their impression and their words and their thoughts, but also the punctuation. And the thought of just having a natural conversation. And it makes me think back to Dragon Naturally Speaking, which we were using 20 years ago, is that this is actually naturally speaking, with the intent of just be the doctor, don't worry about what you say, just get the right content in there, and then the AI will help form it correctly.
Yes, and it's actually made quite a splash. I mean, I've seen some of the early iterations of this process, and it does engender a lot of excitement amongst radiologists. I do think you alluded to an important point, which is if you have already created a succinct and efficient system for dictation, it may not be as exciting.
Right.
The people who have been dictating to transcriptionists, there still are a few out there, who haven't made the switch to voice recognition, I think will be particularly excited about this.
Yeah.
So we've spent a lot of time actually creating a dictation system that is incredibly efficient and very effective in that it allows the creation of a lengthy report with relatively few utterances, right? By the use of macros in dictation. We have really gotten to the point where we're very efficient and succinct, and we have spent a lot of time coaching our radiologists not to have the expansive flight of ideas type dictations.
I think you refer to that as Kentucky windage.
No, I call them the poets.
Oh, yes.
The radiologists that expound upon small details in imaging findings and whatnot. And we've really tried to discourage that in our radiologists and say, just give the meat of the report and not all the additional extraneous detail. So I think that what we stand to gain from ambient dictation is slightly less than what a typical practice who is starting from, say, a point further back. But that said, we have seen a great benefit to it in that the punctuation, the dictation commands that are required are greatly reduced. No more period, new line. In fact, we call our own project on this the No New Line Project, so that our radiologists don't have to punctuate so much. And I would say, too, it doesn't seem to have added much in terms of the actual content control of a radiology report. And again, it might be that we are just further along in that than most practices.
But I was going to ask you about that and how you feel about, so you depending on what system is holding up conversational or ambient dictation, how you feel about it goes into this black box and then you get a report out, and if it actually changes some of your commentary or adds things to your report that you didn't intend on, and how you have controls around that, or how we're approaching that.
That's a great question, and actually it has been a basic precept of all of our dictation development that we really don't like to add diction that the radiologist didn't say, and we don't like to remove diction that they did say.
Right.
And so one of the ways we have addressed that is by using colored font. And so we actually color the font in any given report as it's being created based on the origin of that diction. So if the radiologist said something, it's in one color. If they use macro-driven dictation, it's in yet another color. And now we have a third color for anything that's added by the artificial intelligence dictation engine.
Yeah.
And that way, the radiologist can, at a glance, see very quickly if there's been any alteration. We are yet to see exactly how much alteration will be associated with this, and we, again, do try to limit it. But it's a necessary evil, I think, of going to this sort of dictation style, that you are going to have a lot more contribution by the artificial intelligence engine.
What do you feel about, and hey, I mean, if you go and look in the market, you'll hear anything from 10 to 50 to 100% improvement in efficiency, and that's just not how I look at it. But I am curious what you think the practical implication is for radiologists. Do you think of it more as like, hey, this is a real efficiency boon, or do you feel like this is just a quality of life upgrade? But whatever your reading style is, it's not going to change dramatically.
Yeah, and I agree with the latter statement. There's no question that, and it depends on where you start this race.
Sure.
Again, as we referenced earlier, if you're starting from a point so far back, this can be an enormous leap in efficiency. But I think that we were so far along already, the efficiency gains we might potentially garner from this, I think, are relatively limited.
Yeah.
So we're looking at it more as a quality of life thing where a little less effort is required in the creation of a report than it was previously. But I think the contribution to the actual quality of our reporting, accuracy of our reporting, or timeliness of our reporting will be small.
Yeah, I agree with that.
Well, let's move on and talk a little bit about our strategic selection of AI algorithms.
I've heard you comment on when you look at the AI market, and especially what radiology groups are doing to try to address maybe an AI need, is that sometimes there's some hungry shoppers. And it's hard to know what you really need if you're at the grocery store and you're hungry versus if you made a list before you got there.
Are we going there with the hungry shopper analogy? I love this analogy. It is basically that everyone has an appetite for artificial intelligence. They all know it's the hot thing out there, and they all know that they want it, but not exactly in what manifestation or how it will be utilized.
Right.
And I think it comes down to they don't know what problem they are trying to solve. And so, yes, I always analogize this as these practices being hungry shoppers, that they have this appetite, but they don't really have a meal plan. And so they go to the grocery store and pick the things that look interesting or perhaps are colorfully packaged. And then they get home with their shopping basket and they have kale and gummy bears and sardines, and it really won't make a proper meal.
Right.
Because they didn't go with a plan. They didn't identify the problem they had to solve, the specific hunger that they had to satiate. And so they end up with kind of unrelated and possibly even unnecessary artificial intelligence algorithms.
Yep.
So we at vRad have possession of data and have done an analysis of the sorts of pathologies that are missed, the pathologies that result in medical malpractice cases when missed, and the sorts of issues that might put patients at risk.
Yeah.
And through that analysis, we've identified a number of pathologies that we felt were salient and the most important ones to address. And that's what we've then focused our efforts in building algorithms. Can you talk a little bit about how we've operationalized those algorithms that we selected that way?
Yeah. So once we've selected an algorithm and actually built it, we clearly have to figure out, okay, how do you put it into production? How does it work once it's in the live platform? And then not just how do you measure it, but how do you manage it? And those are two different things, because you want to measure the performance of whatever you're doing, but you want to manage it in a way that you extract the biggest value for the benefit of the patients, the clients, and clearly the radiologists. And so one of the things we try to manage is if we know model A versus model X will have a higher value for potentially preventing a patient care issue, we will amp up the frequency at which that will produce a prioritization in the work list. And then we will tune it so that after the radiologist has dictated their report, the model will actually look at the NLP data of the dictated report versus what the model suggested was going on. And if there's a high enough differential, it will then kick it automatically back into QA so that you can spot it like that in real time to go make a correction if one is necessary. And so managing it in real time, that has, I think, changed our practice, especially from a real-time patient flow, because it's not common that a radiologist makes a miss. But when you do, having the ability to actually spot it, find it, and correct it before care is ever rendered or prevented from being rendered to the patient, I feel like that's been a big deal for us.
Yeah, it has indeed. And we're asked frequently why we effectively are doing a back-end comparison of the radiologist report content and the artificial intelligence output.
Mm-hmm.
And we're frequently asked, why don't we present the AI output directly to the radiologist at the time of dictation? Why don't we?
You tell me.
Oh, it's the FDA.
No, I understand. There's you don't want to pre-inform the radiologist or
prejudice the radiologist.
You don't want to prejudice the radiologist. And I also think it's a very interesting way of doing it the way we've got it right now is that because we're not prejudicing the radiologist, because we're just prioritizing the case, the rad can just be the rad, and then you're not having them look for things that might not actually be there. You're not having them go spend extra time agonizing over something that might not exist, because the AI also isn't always right. And when you look at any AI model in the market, not everything is 100% sensitive or specific. And so you have to know that, because when it goes back into QA, if and when that happens, then you've got another pair of eyes looking at it and they can confirm, no, the AI got it wrong, or yes, this does need to go back to the RAD. But rather than having the RAD every time something gets prioritized have to sit and agonize over it, I feel like we're doing it in a very productive way for the practice while the AI models continue to mature.
And with our approach, we're able to constantly tune the model and constantly improve its performance by monitoring the sensitivity and specificity of its outputs and feeding that information back into the convoluted neural network that ultimately produces those outputs.
Yeah.
All right, well, let's move on to data and normalization.
Oh, the most exciting topic.
Actually, Joe is facetious because he actually drove this at vRad, and it's been of enormous benefit to us. In fact, I freely confess I did not recognize the implications for our standardized, normalized database that we built probably at this point 15 years ago. It took a long time. It ate a lot of budget. It took a lot of development bandwidth, and I was almost continuously frustrated by that process 15 years ago and would constantly question the potential value. And now, of course, I look foolish. It has been the greatest boon, I think, to vRad. It has enabled essentially all of the processes we've developed since that time.
Yeah.
I'll let you expound upon that further. But.
Well, I think data normalization is almost like, you remember that book we probably read as kids, If You Give a Mouse a Cookie? There's always something else that needs to happen, because once you have something that works really well, you realize, oh, well, what if this also worked really well? And so you're always trying to add on to that. But you flash forward to today, and what do we know about AI? Structured, normalized data creates the best models, whether that's for NLP purposes or whether that's for image AI detection, or whether that's for LLM responses outside of radiology. The better categorized, curated, real data you have, the better the AI model will run. And it is a journey from start to today to wherever you're at in that journey. But you have to start, I think, by asking questions. And I mean that in the following, 15, 20 years ago when we were starting down this journey, you were asking the questions of, well, how many studies did we do last night? Or how many RADs didn't show up for their shift? Or what was our average TAT for stroke patients? And if you don't have normalized data, then operationally, for my team, it was like every day we had a project of, well, now we got to go figure out how many things we did or how long it took us to do those things. And so it became clear very quickly to do a better job operationally, we needed cleaner data. But the output of that is that now we have cleaner data, we can make better decisions, and now we're looking further into the future based on the data that we've got and how that works into the future. So from procedure standardization, and if you zoom out and you think about all the facilities we serve, whether you're in New York, you're in Texas, you're in California, you send the CT head to vRad, it's just CT head. It's not CT brain, not CT brain without, not CT head / brain, because every single hospital and health system has kind of curated their own selection of procedures. And if as a radiology practice, you've got 10 imaging centers and you let them all order things a little bit different, well, then at the end of the month, you want to say, how many studies did we do? Oh, how many CT heads did we do? Well, now you've got 2 or 3 different answers for the same question because you have to look at it 10 different ways. Normalizing gives you an answer like that. And now you're saying, but what if? And I'm excited about that because that's what we're actively doing with the databases. We're saying, what if we had? And now we're going out to incorporate all of the AI findings, all of the sensitivity and specificity, what we're doing with report categorization. So when the radiologist speaks, we can actually categorize the language that they used so that when we can go back and actually look at patient records to say, based on age, gender, reason for exam, and report type, what's the incidence of various types of findings? And you can never do that if you didn't start with, well, are these all CT heads or not? And so it starts small, but man, it balloons. And it's a very exciting thing in terms of what it means for the future. That actually reminds me of that saying, right? When was the best time to plant a tree? Well, it's 20 years ago, but the next best time is today.
It's today.
And so
that's true.
You can start normalizing today and it'll make you better tomorrow and the next day and the next 10 years.
Yeah. That sounds discouraging that we're talking about the time it takes and how much earlier than now you should have begun this process. But it is worth noting that all of this is built into our platform now and is available not only to us for our data-driven decision making, but also is available to those client sites who have contracted to use the vRad platform to perform their clinical duties, but also to manage their practice.
Right. Right. You get the benefit of that 15 to 20 year run of us trying to figure out how to normalize, how to standardize, how to automate, and it's just out of the box today. Ben, will you be at RSNA this year?
I will be. Are you going?
I'm going too.
Fantastic. We will both be at RSNA in the vRad booth, and we will be set up for platform demonstrations. So if anyone would like to see in real time how these processes are effected and applied to our radiologist workflow and practice management in general, please feel free to stop by our booth at RSNA. That's Virtual Radiologic. We'll be right towards the front in the North Hall at RSNA, and again, giving live platform demos so you can see that this is all real, all these things that we are discussing. All right, well, let's talk a little bit more about AI and how we've already integrated it into our systems. And it's funny to think that we've actually been working in artificial intelligence for a very long time. You might cite our beginnings in 2015, which is when we collaborated to build our first image detection algorithm.
Yep.
But really, it's more than 15 years ago that we started using natural language processing for the categorization of our radiologist reports and the detection of internal inconsistencies in reporting, reporting prompts for certain report content. All of that has been going on at vRad for much more than a decade. So let's talk about how we have taken what really is artificial intelligence, natural language processing. We've always kind of referred to them as different entities, but really they are two sides of the same coin. That essentially artificial intelligence in most people's minds means pathology detection on images.
Right.
But the contextual interpretation of the written word, which is affected by natural language processing, is certainly an application of artificial intelligence. And it's been around for a very long time.
Yeah, it really has. And starting with the normalization, all of that data, that basically allows you that all of the downstream impacts. And we should probably talk about how we prioritize studies, because having normalized data means you can actually treat all of the same types of patients the same way, depending on what's going on. But same with how we retrieve priors. And I don't even know where to start in that. When you think about how the data was normalized, where do you think the best logical step is? How we prioritize it on the work list, or what the RAD sees when they open it up?
Well, I think all of it is pretty important, but ultimately, I think it's the prediction of the likelihood of a critical finding in a given procedure that is the most important aspect of our study distribution.
Yeah.
That we actually, by using natural language processing, have determined the incidence of critical findings by procedure. And so we use that information to then expedite certain procedures we know to have that higher likelihood of a critical finding. And I think that is probably the single greatest contribution that NLP has made, but mainly because of our emphasis on emergency medicine and the importance of prioritizing these studies. But you did mention the selection of prior studies, and that was an important step as well. The ability to identify the most relevant, anatomically related, modality matching prior study is very important for our workflow. Mm-hmm. Right? And it drives, well, you know better than I do, the sorts of things it drives. It drives caching of prior studies, so we know which ones are most likely to be relevant and therefore should be prioritized in transfer to the radiologist. And it allows us to make the radiologist workflow more efficient, because we can automatically launch that most relevant prior at the time the radiologist opens the current study. So that's been, I think, a huge contribution.
Yeah. Yeah, and if you think about how it works from the start, because we've normalized the data, we know what all the studies are supposed to be. Because we know what priors are on the patient's record, we know if we have them or if we don't have them. And so we will proactively, because we've got this great data coming in, we'll know, well, wait, we don't even have the prior. We know the prior is required. We'll prevent it from going to the radiologist, and we'll go take action and try to get that prior before the RAD ever opens the case, so that the RAD can just be the RAD when they open it, and we're not wasting their time on clerical work trying to make sure the prior is even there. And then to your point, in terms of how they open that next case, the fact that we've put in so much effort to make sure that we've prioritized the best next case based on what is for vRad a very, very high ER patient mix means that we are not prioritizing places, we're prioritizing patients. It doesn't matter where you're from. If you fit a certain category where we know you have an elevated incidence of critical finding, by virtue of the demographics and patient information coming in, you get prioritized, and so the RAD can just click the next case. And by virtue of having this NLP data, we've been able to actually affect real change in getting the sickest patients read first.
And this all naturally leads to then our next point of integration of AI, and that is, if you consider natural language processing is able to look at a report and parse out the relevant findings in that report. And that's how we've calculated the incidence of critical findings by procedure.
Right.
So we are also using artificial intelligence to essentially assign a number score for relevance based on recency, anatomic relationships, those sorts of things, to select the most relevant prior study. And if you combine those two things, it leads us to the highlighted prior findings tool. You know, our various features are named often at inception by the engineering teams.
Yes.
And we always say it's just a working title and that the marketers will go back and fix things at some later date. But then the name tends to stick.
Right.
And so we have some truly awful names for some of our tools.
But incredible technology.
With terrible names. So the highlighted prior findings tool, not the product of our marketing division, is a brilliant idea where we have determined the most relevant prior studies and then parsed from the reports on those prior studies, those findings that we have deemed to be significant or to require follow-up.
Yep.
And we've actually tuned the natural language processing to hone on follow-up related language so that we can identify those things that have been reported in prior reports and require the radiologist reading the current study to comment on them.
Yeah. Well, because we've got the NLP running, when the RAD finishes their report, now we can review the report and automatically give them a flag if, wait, you need to say XYZ things for MIPS reporting, or for, in the event that you've said a critical finding, the system knows, oh, there's a critical finding. I'm going to go dial the phone on your behalf now, because we can read the report, and with NLP, it knows the context of the report, and so then we can take actions because of the data that's already been normalized prior to the RAD ever opening up that patient.
That's right. It does go to that next level. So we're able to look at all the things that have been previously reported and present those in bulleted form to our radiologists. But then we can apply the same sort of process to the current report that the radiologist has produced. And we can make sure that they are MIPS compliant, compliant with various payer reimbursement requirements. Basically, anything. The state of Pennsylvania requires reporting of incidental findings. We've got that built in. So all of these sorts of things, internal inconsistencies, right-sided findings in a left-sided procedure. We can identify any of these sorts of issues and give the radiologist prompts and direction in the course of the creation of their report.
Yep.
And that's all through natural language processing. One manifestation of our use of natural language reporting to control report content has been our project in aspect score reporting.
Sure.
And I think that one ultimately led to a peer-reviewed publication by vRad. But we showed that in acute stroke cases, which we could identify due to the normalization of our data,
Yep.
the requirement that aspect scores be reported was a MIPS measure that we took on some years ago. And we discovered that our compliance was a shockingly low 5%. And that is in the face of pretty much universal demand for aspect scoring on stroke patients in the ER clients we have across the country. And by implementing natural language processing driven prompts and checks for that specific content in radiologist reports, we actually, in the course of 1 year, raised our compliance on that particular measure to 94%.
Wow.
And I encourage everyone to extrapolate from that experience and realize the kind of control that a practice can take of reporting content. And it's not dictating thoughts into radiologists' heads or channeling their clinical decision making in any way. It's simply assuring that certain informational points that are broadly desired by our referring clinicians are included in those reports where it's relevant.
Right. And you didn't have to send an email.
And you didn't have to send an email. And again, another manifestation of artificial intelligence that I think is underappreciated. In fact, I've said many times in the past, if I could pick one or the other of those AI manifestations and only have one, would it be natural language processing or image detection algorithms? And undoubtedly, I come down on the natural language processing as the greater contributor.
Yeah, that's certainly been the case for the last 15 years. This probably goes without saying, but if you're in a radiology practice with more than one person, now you don't have to go try to manage all of the other radiologists as, remember, you have to say this if it's this type of patient or if it's in this state or whatever the diction is supposed to be, so that you're reporting within the compliance of whatever the requirements are. It's just automated. And that has been incredible for us because we don't have to go send a message to 500 plus people every time there's a reporting requirement thrust upon us. Just go configure the system, and now everybody just continues to be a doctor, and it automatically works.
Yeah, you're taking me back 25 years to my old private practice, and I used to cite that as an example of exactly how not to manage report content. Basically, they would send an email out to all the radiologists in the practice.
They're just the best.
and I would always look at it and it would say, unless you report on the IVC and aorta in an abdomen ultrasound, we will not be paid. And I remember reading that and thinking, about 1/10 of our entire practice will read this email. About 1/10 of those people will actually comply, and that compliance will last probably somewhere between a week and a month before they return to their old process. Whereas what we do is build those prompts in, make an automated check for required content, and alert the radiologist if we don't see that it is present.
Right.
You did mention before, and I think we should call out the fact that we can identify critical findings in a radiologist report, and that we have actually connected that to our communications processes.
Yeah.
So, well, you deal with that more on the operations side, so I'll let you talk.
Well, so we've integrated into our phone system. So, Ben and the medical leadership team have effectively categorized all of the critical findings that for our practice require a verbal communication out. And when one of those phrases is uttered, because it's a requirement that we go and make sure that gets communicated, we program that into the phone system. So because we have normalized data and we know what facility you're from, and we have standardized phone numbers, and we know the referring physician's cell phone if we've got it, or the ER's phone number if that's what we have, we will actively have the automated phone system go out, dial that number, and actually ask somebody to stay on hold to then transfer the call back to the radiologist. So that as a rad, I'm not sitting on hold for 5 minutes trying to hunt somebody down. The system just works. And then if the system finds the nurse, but we don't have the doctor yet, it'll actually go to our operations center. We'll make sure we get the right person and then pass it to the radiologist. But again, we're trying to eliminate clerical work so that the doctors can just be the doctor, but also get the benefit of all of these really cool AI tools in the background that are helping just the flow of patient and the flow of traffic 24/7.
All right. Well, we've been through a lot here. The importance of standardization and normalization of data and its application to operational and clinical processes. It's incredible, all the manifestations that we see of natural language processing and AI across all of our basically daily activities. And it really has been a boon that I think began with the creation of our standardized data warehouse.
I think so.
So that is, I guess, the first step that we're encouraging everyone to take.
Yeah. Hey, standardize your data. It will set you free.
It will indeed.
Yeah, and I will say, like, with the current pace of innovation in the market and with the current pace of AI, there's a saying I've heard on a number of AI
Podcasts
I've watched, but the saying is, AI never sleeps. And that feels more real today than ever when you wake up and there's some new announcement from one of these huge AI companies. But the reality is, AI never sleeps. What are you doing to make your practice better with AI? Whether you started 15 years ago or you're starting today, standardize your data, the future will get better.
And it is moving very quickly. I'll drop another line I've heard frequently, which is people complain and say, well, this AI got this wrong.
Oh, yeah.
Or did this silly thing. And some of the outputs are out there. There's no question. But I've often heard it said, the AI today is the worst AI will ever be. And that, again, speaks to the pace of its evolution. And we can expect, I think, very accurate AI algorithms and outputs over the coming months or years, and it will be strikingly efficient and effective.
Yeah, and I will say too, like, AI seems almost overwhelming to me if I just look at it and think, oh my God, what's happening with AI and how do I make it work for me? And I don't think the goal in radiology or any other market is actually AI. The goal is, how can AI help me? And if you start with that position versus how do I get to AI, I actually think you make a lot more progress because you're not putting all of the weight of your problems on AI. You're just saying, here's all of the problems. Now let me ask some questions. How can AI help with me?
Identify those problems that you need to solve first.
Yes. Yeah. Start with the question.
Absolutely. Well, I appreciate you joining me, and it's been a pleasure as always. So thanks to our audience for tuning in to Field of View, our radiology podcast here at Virtual Radiologic. So once again, I'm Dr. Benjamin Strong, Chief Medical Officer, and I've been joined by Joe Schmugge, our Chief Operating Officer at vRad. Hope you enjoyed this, and we'll see you on an upcoming podcast.